Good morning, guys. Today we're going to continue with our topic of factoring, and this would be notes 2.07. And so last class we learned how to factor trinomials that are not perfect squares. Okay, but all the examples we did had a leading coefficient of 1. The leading coefficient, another way to think of the leading coefficient is this term right here. Okay, so we had a leading coefficient of 1, and today we're going to learn how to factor trinomials that have a leading coefficient that's not equal to 1. So it's the number in the front can be 3, 5, any number different than 1. And so we're going to begin truly using the bottoms up method. Okay? And so let's look at what the bottoms up method, what the steps are for that. Okay? So the steps are the following. So it's pretty much the same idea as what we did last class. We're going to multiply the first and the last number. And we're looking to find two numbers that multiply to give you a times c, and then those two numbers need to add to give you the middle number. So this is the middle, and then we would usually multiply a and c, right, to get this number here. So we're starting it off the same way. The only difference is that we're going to divide the constants by a factor of a. Okay, if you get a fraction, then you reduce that fraction, and it'll make more sense once we start working on examples. So, so there's two situations. If you can divide, then you leave it as a constant. You write the answer that you get. If you can't divide the fraction, then you bring the denominator up. Okay, and so let's go ahead and jump to the first example. And like I mentioned last class, these will make a whole lot of sense once we start looking at examples and working on examples. Once we get practicing, I think we can get the hang of it. All right, so let's go to example 1. All right, so we're going to make a table. And let me see how much space I have here. Yeah, that looks good. And we're going to multiply the first and the last. And so multiply on the left, add on the right, and we want to multiply to get 20, and we want to add to get 9. So we can try, the first combo, and the first combo would be 10 times 2 is 20, but 10 plus 2 is 12. Yeah, but that's not the number in the middle, right? So is there another combo that works? And you would say, yeah, what about 4 and 5? Because 4 plus 5 equals 9. Yeah, that matches the middle term, and I got 20. So they both check off, right? And so let me delete this right here. Okay, and so now this is where it gets a little bit different, because if you notice, the number in the very front is not a 1. And so what we're going to do is the following. We're going to set it up like we would last class. So we would set up two parentheses. And the variable is a, so I put a and a. And the combination of numbers that worked was positive 4 and positive 5. So what we're going to do now is a little bit different because the number in front is not 1. It's different than 1, right? So what we're going to do is we're going to take this number and divide it out. And so the number in front was 10, so I'm going to divide both of these numbers by 10. Now, can I reduce these fractions? Yeah, 4 over 10, they're both divisible by 2. So that's 2 over 5. And then 5 over 10 is 1 over 2. Okay, and this is why it's called bottoms up. This is what we're going to do. Let me use, I'm trying to think of what color to use. Let me just use purple. Okay, so what we're going to do is we're going to take these numbers and put them in front of the variables. So that's going to give me, if I move the 5 in front of A, I'm going to get 5A plus 2. I didn't move the 2, right? I'm moving the 5 to the front of A. And then I'm going to move the 2 to the front of A. And that should be my answer. 5A plus 2 and 2A plus 1. Okay, and we can check it out. Is it going to work? Can we check it out to see if it's going to work? Yeah, definitely. So let's try it out. Let's see. Let's check it. Okay, so to check it, we're going to have to multiply. We're going to multiply 5A out, and 5A times 2A is 10A squared. 5A times 1 is 5A. And then, let me pick a different color. We're going to multiply 2 times 2A and 2 times 1. 2 times 2A, 2 times 2 is 4, so 4A. And 2 times 1 is 2 plus 2. Okay, combine like terms, we can combine the a's. So we get 10a squared plus 9a plus 2. So does this match the original problem? Yes. Is there a 10 in front? Yes. Okay. So again, we're gonna try this again and see what we get. Okay, let's try it again. Example 2. We're gonna set up our table. Multiply, add. and we want to multiply 4 times 7. That gives me 28. And the number in the middle is negative 16. Well, I can try the first combo, right, that we did. 4 times 7 is 28, but 4 plus 7 is 11. That's not the number that I want. So can we think of a combination that will work? 4 times 7. What about, since I want a negative 16, right? What's negative 2 times negative 14? Positive 28. What's negative 2 plus negative 14? Negative 16. Awesome. I got them. I got both of them, right? Okay. And so, again, set it up like we did, like we set up our answers last time. The letter is X. The combination that worked was minus 2 and minus 14. But again, this is a little bit different. And it's different again because the number in the front is not 1. The number in front of x squared, or the variable squared, is not 1. So when this happens, we have to make sure and divide by that number. Divide by 4, divide by 4. Okay, and then in the next step, we're going to reduce. 2 over 4 becomes 1/2. 14 over 4, they're both divisible by 2. 14 divided by 2 is 7. 4 divided by 2 is 2. And so we're going to bring this bottom up over here and this bottom up over here. And so we end up getting 2x minus 1 and 2x minus 7. So that should be my answer. And let's check it. And I'm just going to check the first two. Okay, so let's check it. So it's 2x minus 1 and 2x minus 7. And so we're going to multiply 2x times 2x and times 7. 2x times 2x is 4x squared. 2x times negative 7 is negative 14x. And then we're going to multiply negative 1 times 2x, and negative 1 times negative 7. Negative 1 times 2x is negative 2x, and negative 1 times negative 7 is positive 7. Okay, and we should see that we can combine the x's. They're both negatives, so they're going to add. What's negative 14 minus 2? So bring down the 4x squared. Negative 14 minus 2 is negative 16x. And bring down the plus 7. So does this match the original problem? Yes. Okay. So that was 2 done. And we have 2 more to go. So hopefully, as we're practicing it, it's making more and more sense. And again, the idea here is, it looks like, you know, one of the problems we did last class, but we just got to check. We just got to check and see what if there's a 1 in front or not. Because last class, all of these had a 1 in front, if you remember. So because it doesn't have a 1 in front, we're going to divide at the very end. We're going to divide by this number in front. Okay, so let's create the table. Multiply and add. So I want to multiply the first and the last. That gives me negative 24. And then the number in the middle is 5. Okay, and let's check. See, 2 times negative 12 is negative 24, but 2 plus negative 12 is negative 10. So that doesn't work. Is there another combination that works? See, 24, and I want to get a 5. What about, sorry, that's a different color. What's 8 times negative 3? It's negative 24, right? And what's 8 plus negative 3? It's positive 5. So those two worked. All right. Then we're going to set up our parentheses. The letter that we're using is M, and the combination that worked was positive 8 and negative 3. Okay. And what was the number in the very front? It was a 2. So remember, we're going to take this 2 and divide it. Divide it out among the numbers. Okay? So, well, this one works out nicely because 8 divided by 2 is 4. And can I divide 3 by 2? No, so I'll leave it. But since we have a fraction, any fraction that we have, this fraction changed to a whole number, so this one's okay. But here we have a fraction. If we have a fraction, we have to remember in this method that we're using that we have to take the denominator and move it up to the front. So I'm going to copy the first answer, and then the second parentheses, I'm going to move the 2 to the front, and then copy the m minus 3. Copy the minus 3. And so that should be my answer. M plus 4 and 2m minus 3. All right. Let's do one more. Let's set up a table, and probably don't need to make it that long. Okay, so we're going to multiply on the left, add on the right. I'm going to multiply 3 and negative 2. That's going to give me a negative 6. And the number in the middle here, there's a 1 right here. So the number in the middle is actually a negative 1. Let me write that again. Negative 1. Okay. So let's try that combo that we got in the beginning. So it was 3 times negative 2 is negative 6. What's 3 plus negative 2? And that gives us a 1, but we don't want a 1, right? We want a negative 1. So how can I get a negative 1? And what if we switch the signs? Right, because negative 3 times 2 is negative 6. But what is negative 3 plus 2? That's negative 1. So that works. That combination works. And so we would set up our 2 parentheses here. And then this one's like the different one where it has 2 variables instead of 1. So if you notice, in the first term we have x, and on the last term we have y. So first and last. So think of it that way, right? First x's, last y's. So the first thing I'm going to write in the parentheses are x's, and the last thing that I'm going to write are y's. Okay? And what was the combination of numbers that worked? Right? It was negative 3 and positive 2. So I'm going to put negative 3 and positive 2. But don't forget, every year students are always forgetting, is the number in the front, is it 1 or is it different? It's different, right? It's 3. So we need to remember to take this number and divide it. So we're going to divide both of these by 3. And 3 divided by 3 is 1. So we get x minus 1y. And can I divide 2 divided by 3? No, right? So what do we do if we have a fraction? We can already kind of skip a step here. And we can put that number in the front there. So we're going to put 3x plus 2y. And one thing, I'm going to erase the negative 1 here. So right here there's a negative 1 here, so I just wanted to make sure to erase that. And so that would be my answer. So this equals to x minus y, parentheses 3x plus 2y. And for these last 2 examples, remember, we didn't check them, but I encourage you on your own, if you want to check them, just to see that when I multiply these, it matches the answer. Same thing for example 3, right? We didn't check example 3, but you can multiply these and check to see if you get the original problem. But again, guys, thank you for joining me today. I'll see you guys in class, and I'll be there to answer any questions you have, and kind of help you guys out with anything that I can clarify. But I'll see you guys then. Have a great day.